So in this lecture we will understand the single column manometer. So to increase the accuracy of YouTube manometer, the cross section of one limb of the YouTube manometer becomes large so that the pressure measurement is defined by single column. So to increase the accuracy we use the single column manometer, so YouTube manometer. So here this is the this is the area, this is the larger area and this is the small area. Okay, and here so delta H, so here the deflection, that is the delta H. So here the distance will be H plus delta H. So this is the liquid column deflection. So let's try to understand one question. So important question is there. The cross sectional area of one limb of the YouTube manometer is is made 500 times large than the other, so that the pressure difference between two limbs can be determined by measuring H on one limb of the manometer. The percentage error involved with respect to this pressure measurement is, so you have to calculate the percentage error. So what is given in this question? So this area, so this is the area, this area is 500 times of this area. Okay, so this area, consider this side area, that is small a, so 500 into small a. Okay, so this area into height delta H, so area into delta H, that will be same as area into this H. Okay, so from here you can get delta H by H, that is equal to A by capital A. So this is 1 by 500. So if you want to calculate the error, that is H plus delta H minus H, so this is the delta H will be error. So if you want to calculate the percentage of error, that is equal to delta H by H into 100%. So delta H by H 1 by 500 into 100%. So this is equal to 0.2%. So that is why to increase the accuracy, so we use the single column manometer by increasing the cross section of one limb of the YouTube manometer. Okay, so let's try to understand another question. So here this is the YouTube manometer as shown in figure, has water as manometric fluid. When an unknown pressure P is applied at 5 mm diameter limb, the water rises in the limb by 100 mm from the initial level. So if the other limb is open to atmosphere pressure PA, the pressure difference P minus PA. So this is also very easy problem. So try to solve this problem. So this is my handwritten notes, you can download it from the description. Now let's try to understand the sensitivity of manometer. So it is the ratio of manometric liquid deflection in inclined tube manometer to the water column deflection in YouTube manometer for a given pressure difference. So it is the ratio of the manometric liquid deflection in inclined tube manometer to water column deflection in E2 manometer for given pressure difference. So this is the consider this is one section where you have to measure the pressure at that point. So this is a single column manometer. Okay, so the height is H and here the atmospheric pressure, that is equal to 0. Okay, so what will be the pressure? That is rho into G into H. But here if we incline this manometer tube like this, here theta is the angle, so here the atmospheric pressure, that is equal to 0. Okay, and because this is a gauge study is there, so that's why atmospheric pressure, that is equal to 0. So this is L, and this is, consider this is H1, this is H2, this is H3. So this is the case. So how to calculate H? The distance, that is H equal to L sin theta. Okay, so H equal to L sin theta. So let's try to calculate the sensitivity of the manometer. So to calculate that, so we have some assumption are there. First, there is a static fluid, because applied hydrostatic law. So here we apply the hydrostatic law. So the fluid must be static. Incompressible fluid, okay, the compressible, the density is not change. Okay, and third, the neglect the capillary effect. So this is also very, very important. Okay, so this is the area A, and this is the small area A, and this is the column deflection, that is delta H, and here also there is a deflection happen. And if you want to calculate the height, that is L sin theta plus delta H. So this is the L sin theta, and delta H is the entry distance. Okay, so delta P, that is equal to rho m into G into L sin theta plus delta H. So rho of mercury, so this is, there is a mercury is there, so density of mercury into gravitational acceleration into L sin theta plus delta H. So rho into G, L sin theta, and delta H. From delta H you can calculate A into delta H, that is equal to A into L. So from here delta H, that is equal to A by L, sorry, into L. So A by A into L. So that is delta P, that is equal to rho m GL sin theta plus small a by capital A. So this is equation number 1. And delta P of water, that is equal to, so if you want to calculate the delta P for water, for this case, so that is equal to rho of water G into water, so G into H of water. So delta P, that is equal to rho of water G into H of water. So this is equation number 2. So by equation number 1 and 2, we can get rho m GL sin theta plus A by A, that is equal to rho of water G H of water. So G cancel out on both sides. So L by H, that is equal to 1 by rho of m by rho of water into sin theta plus A by capital A. So from here, so this is known as sensitivity. So L by H. Okay, so this is S. S is the sensitivity. So that is equal to 1 by Sm. Sm is the specific gravity of manometric fluid. So Sm is the rho of m by rho of water. Okay, we know that rho of mercury by rho of water. So this is the specific gravity into sin theta plus small a by capital A. So if A is greater than A, so this term is neglected. So from here sensitivity, that is equal to 1 by Sm into sin theta, because this term is left. This term is cancel out. So from here sensitivity, that is equal to 1 by Sm sin theta. Okay, so that's, in that way we calculate the sensitivity of the manometer. Okay, so now let's try to solve one question from this sensitivity. So in order to increase sensitivity of U-tube manometer, one leg is usually inclined by an angle theta. What is the sensitivity of inclined tube compared to the sensitivity of U-tube? So there is a inclination angle theta, and there is a perpendicular angle, that is theta equal to 90 degree. So for that case, S theta, that is equal to 1 by Sm sin theta, we calculate that, and SV 1 by Sm sin theta, and here the theta is 90 degree. So 1 by Sm, because sin theta sin 90 degree value is 1. So 1 by Sm. So if you want to calculate the ratio of sin S theta by SV, that is sensitivity of theta, so angle theta by SV, okay, vertical direction. So that is equal to 1 by sin theta, 1 by Sm sin theta by 1 by Sm. So from here you can get 1 by sin theta. So this is the answer. So this is all about the sensitivity of the manometer. This is my handwritten notes. You can download it from the description. Thank you.